Right, so now let's talk about functions, which we decided were mini programs, okay? Mini programs, okay? And they're also called methods, okay? And methods are sometimes used exclusively when people are talking about functions inside of a class, things like drawball. But other times they're used just to say functions. So these can be used interchangeably in my book, and in most people's book. But member functions, okay, member functions means part of a class. Okay, so like the ball class has a member function draw ball. Okay, the ball class has a member function draw ball. All right, functions are mini programs, methods. You have member functions. What else? Oh, sometimes people will call functions subroutines. In um, Visual Basic, I used to teach Visual Basic, and the name for a function is a subroutine, right? That's very old school. That almost sounds like Basic, right? I think that's it. Yeah, there might be others. We'll get into it if there's others. Um, or ask questions in the comments below. You can't ask questions. I'm kidding. Okay, so functions start with a return type, which is what the function will evaluate to. And so it's like the whole function will turn into the return type. Okay? And we'll talk about that. That has to do with where it's called when it's invoked. But you could have a return type that's a number, like an int or a double. You could have a return type that's an object, like a ball, right? That can work. You can also, string whatever. You could also have no return type, which is void. And we've seen voids before. Actually, we see a few of them in processing. We'll get into it. So you could also have a name, which is how you invoke the function. All right, so a function name, which is how you invoke the function. And invoking is a term for starting the mini program. Okay, calling, calling, invoke the function, call the function. I think those are it. And that's code for start the mini program. Okay, start the mini program. All right. And so we have a function name, and what's our function name? It could be anything, but we've seen like void, so like void setup. Okay, right? Void draw public static void main. A lot of void functions, right? So these are all setups this function's name, draws this function's name, and main is this function's name. These are all actually functions we never actually explicitly invoke. Though you can explicitly invoke them. They will work if you call them. But we'll get back into that. So return type, function name, and then we're going to have a parameter list. Okay, and those have type, name of parameter, type, name of parameter. And those keep on going, right? You can have as many parameters as you want, and those are saying these are the pieces of information the function needs to get started. Okay, and so you might say something like, let's think of a fun example. So if you want to write a function, right, that let's do a function. I'm gonna erase this. Okay, so let's say I had a function that took the average of three numbers. Okay, so there's three tests in this class, right? And so you want to know at the end of the semester, you want to know your average of these three tests. So you drop it into this function, and it tells you your average. Simple program, right? So what is going to be the return type? Well, the answer to the question, what is the average of this program? Okay, it could be a whole number. It could also be a decimal. All right, so some sort of float or double, right, would be a good return type. So let's go double. Okay, the function name is going to be average, I don't know, three tests. We can make it more general, average three scores, because it's really just averaging any three scores, right? Or average three numbers, but we'll do scores to scores. And param list, well, what does it need to average the three test scores? If someone said, I want you to average the three test scores, the first thing you would say is, hey buddy, give me some test scores to average. Hey pal, what do you think you're trying to pull here? you would go off on them. Our test scores aren't decimals, right? I mean they are on like Blackboard, but in real life they're not decimals. You always give whole numbers. I guess you could give a half point. I don't know. We're gonna pretend they're whole numbers. Int T1. Oh, come on, dude. Test 1 int test 2 int test 3. Okay. All right. So those are the parameters. And so what this is it's a little machine. All right. It's a little subprogram. But what this subprogram does is it takes in values. Okay. In this case, it takes in three integer values and it returns a double. Okay, so it takes in three integer values and it returns a double. Okay, and that's what we're going to call average three scores. Okay, now things get fun. All right, so let's say we write this. We're going to write this program. Okay, and what we're going to do is we're going to return these things added together. Test 1. I should have just called it T1. I'm going back. Sorry. This is the worst. I'm going to one day make these much better. But right now, I'm going to just keep on making mistakes. I guess that's good though. That's programming. That's the real programming. You're seeing the real stuff in T3. Okay. Sorry. T1, T2, and T3. The three Terminator movies starring Arnold Schwarzenegger. The jokes. Bringing the jokes. Oh my god. Oh wow. Okay. T1 plus plus. This is actually terrible. It looks exactly like the plus sign. Oh my god. Oh my god. Oh my god. 3. Okay. And that's what we're going to return. That's the answer to our question. There's an issue here, right? And the issue has to do with how, and some of you were asking about this, so it's a good time to go into it. And that is the idea of casting. So if I do 5 over 3, all right, what it gives me, so 5 divided by 3 should be some sort of decimal answer, but instead it gives me 3, it'll give me 1, right? So 3 goes into 5 one time, and then it won't even do the decimal, okay? And that's because in C++, if we had, I mean not C++, in Java, and in C++ actually, So in Java, an integer divided by an integer the integer divided by an integer always gives an integer answer. So an integer divided by an integer always gives an integer answer. So 5 over 3 will give us an integer answer because those are both integers, all right? But 5.0 over 3 will give us the right answer, okay? So if one of these is a double, it will go to the thing of higher precision, okay? So the double has more precision than an int, or a float is more precise than an integer, right? And so then it will default to that, okay? So if one of these is not an integer, is a double, then it will default to being a double. So one thing you could do is you could make it 5.0 or 3.0, right? And that'll work. You could also, so that'll implicitly cast it. And what they actually say is, if this is a 3.0, the 5 gets upcasted to a double. So if you ever hear the term upcast, which you won't, no one uses it. You could also do this if you want to cast something, all right? And so I know it looks weird, but it's like parentheses, the type, parentheses, and then the thing you want to cast, okay? Parentheses, the type inside parentheses, and the thing you want to cast, okay? And so casting means, for this operation, pretend that this is a double value, okay? Just for this operation. And since this is a double value, this gets upcasted to a double, we're all good, okay? You can't do this. And this is a big one. So double 5 over 3, okay? This will not work, okay? And the reason is because the first thing that happens is what's in this parentheses. So it'll evaluate 5 over 3. And since 5 over 3 is an integer over an integer, it will come back with the value 1. All right? So it evaluates what's in here first, and so it'll come back with the value 1. Well, now we're kind of in the same problem we were before. But then what does double 1 do? Well, it makes it 1.0. So it's the worst of all worlds, right? So you got to make sure that either the top or the bottom is a double for this thing to evaluate to a double, okay? And we could have also passed in double values for T1, T2, and T3, and that would have been okay if that's what we wanted, all right? Otherwise, we can just say divided by 3.0 in this case, and that'll implicitly cast it. Or, do parentheses, double parentheses, right? If any one of these are a double, this whole thing will turn into a double. Because if T1's a double, T1 plus T2, well, that'll be a double, plus T3 will be a double, divided by 3 will be a double. We're golden, okay? So that's kind of the rule of thumb. Make one of these things a double if in the operation. Cool. All right. So let's finally talk about parameters, because students get thrown off by that. And so I'm going to invoke this function. So somewhere in main, I'm going to say, you know what? Now that I have the 3 score, so I asked the user for score number 1, they put it in the computer. I asked the user for score number 2, they put it in the computer. I asked the user for score number 3, they put it in the computer. And I now have 3 test scores. I was about to put 54. No. This student knows what they're doing. 94, 93, and 81, because it was the end of the semester, and they were just kind of like, okay, I'm done. We all feel that way right now. Average 3 scores, okay? and we could say 94, 93, and 81. All right? So that means 94 is passed in for test 1, 93 is passed in for test 2, and 90 and 81 is passed in for test 3. Okay? Now, passed in, what does that mean? That means for this run of the function, it's like the first lines of code are T1 equals 92, T2 equals 93, and by 92 I mean 94, and T3 equals 81. And then we run this function. Well, that makes sense because now T1 has a value, T2 has a value, T3 has a value. Divided by 3.0 is going to evaluate to some sort of double, okay? And what's that double value? I should have just gone with numbers. So 94 plus 93, I think it's going to be 87. I think 87? Maybe it'll divided by 3. 89! It's an 89.33. Ooh, is that teacher gonna round them? I don't know. We'll find out. Stay tuned. Alright, so the answer to this question, what's being returned is, for this particular run of the function, right? For this particular run of the subprogram, it's gonna be 89.3. Okay? So, what does that mean here? Well, that means this evaluates to 89.3. So where you call it, it's almost like, it is exactly like, not almost like, it's exactly like this will, when the program runs, will be replaced by the value 89.3. Okay? And that means a double function can be treated as a double number. And what do I mean by that? Well, I could store it into a double. I could say double average equals average 3 scores, whatever. And this is going to return a double, like 89.3, and I could put it in the box that says average, and that's all good. So this side is going to evaluate to a double, and so I can store it in something. Okay? What else? There was something else. The double is going to evaluate to a double. If it's a void, you can't set it equal. It cannot be on the right-hand side of this because it's not evaluating to anything. Okay? Oh yeah, so these things is like it sets them at the beginning. Oh, one more thing. So I could also just put in, like, I could also have scores, right? And my first test equals 93, and my second test equals 88, and my third test equals 97, right? Something like that. And then we could say double average equals, and then we can just put these in, right? So average the scores, my first test, my second test, my third test, okay? I've passed all three in as the parameters. Well, what does that look like? Same thing. There's no difference. These are just variables, right? So it's like, for this run of the function, we're gonna say T1 equals, okay? It's like this. T1 equals my first test, right? My first test is 93, so T1 equals my first test. We'll put 93 in the T1 bucket, and then we can run this function. So that's all it is. These are, the names of these don't matter. The types matter. So the names of these are how we refer to them in the function, but they are not like special. So sometimes students think they're special or they have to match these, or no, they're slots. So this is saying, you know, to start this function, you better give me 3 ints, okay? And let's write this explicitly. So this is saying, to start average 3 scores, you better give me 3 ints. Okay, so the function's telling you that. The function's saying, to start me, you better give me 3 ints, all right? Or else I can't do my job, right? And then the function is saying, I'll make the first int you give me T1, all right? And I'll make the second int you give me, well, I'll call it T2. And I'll make the third int you give me, I'll call it T3. And then I'll run this, and I'll make a little calculation, and I'll send back the value. And that's what'll be going on. So that's the idea. These are little slots, and they can hold any integer for a particular run of the function. Okay. Sometimes I say, I don't know how helpful this is, but I'll do this analogy anyways. Sometimes I say, like, you do kind of the same thing with the vending machine. Okay? With the vending machine, there is a slot for a quarter. Okay? And it doesn't define what quarter, there's just a slot for a quarter. And so you put the quarter in so that the vending machine can do its thing. And then you also put a selection where there's a slot for a selection. But you press a button or something, right? Or you give a value. You do give a value, like A1 or something, right? Bringing me memories of Tree Campus, huh? Old Westbury. I call it Old Westbury Tree Campus. And then it outputs, you know, your bag of chips or something. Okay. And so same deal. That's just the same thing. So it's a little machine where you give it some values and it outputs something. Okay. I'm going to stop the video, and then we'll do some concrete. We'll answer a few questions, and then we'll do a concrete function coming up next.